Hello, everyone. Thank you so much for joining me this afternoon in the breakout room. The last session today of Code with Claude. I hope you've all had a fantastic day so far. My name is Margot van Laar. I am an applied AI engineer at Anthropic here in London. And this afternoon, we're going to be talking about the prompting playbook. And prompting is arguably one of the first skills, if not the first skill, that we had to learn as engineers when we first started to work with LLMs. And even now, it continues to be one of the most critical skills to building effective AI systems. So today, we're going to discuss some best practices in the context of two practical scenarios that you're probably encountering at work. The first is where you have an existing prompt in production that you've been maintaining for some time, and possibly you're migrating it to a new model or making a change to the architecture, and for some reason, it's no longer working as well. The second scenario is where we're building an entirely new agentic use case from the ground up, and we need to build the prompt from 0 to 1. Now, in order to illustrate these best practices, I don't just want to give you a list of do's and don'ts. I want to walk through a practical example that's been inspired by real prompts that I've seen some of our customers work with who are building on Claude. So the prompt that we'll look at today is a miniaturized example. The prompts that you're working with are probably a lot longer and more complex than the one we'll see today, but it's representative of some common problems that you might encounter when maintaining a prompt. So imagine that we have a prompt that multiple people have been collaborating on, contributing to. There's no clear owner. It covers a lot of different areas like policy, like tone, processes. We have some patches for kind of previous models that we've migrated to, all mixed together. It's built up and it's complex. And when we're migrating to a new model, we're finding that suddenly a lot of our test cases are no longer working as well as we expected. So what's actually going on here? Well, in order to start unpacking that question, we need a starting point. And that starting point is evaluations. We need evaluations to provide that rigor to understand whether a change to our prompt is actually correlating to an improvement in its performance. And we have different models which have different capabilities and different behaviors. And when you migrate to a different model, it could be that your system is no longer working as well for two reasons. First of all, if the new model might be capable, but it's behaving differently, and therefore we can tune our prompting to fix that behavior. The second case is where actually the model that we're changing to isn't as capable, and no amount of prompting is going to fix that. So we need to have an eval suite to act as a way of testing that regression so that we can apply our prompting best practices to that. So in the example that we're going to be looking at today, as I said, it's going to be a miniaturized example. We'll have 5 test cases in our eval. In reality, you'll have a lot more test cases in your eval suite, but the key thing here is that it's representative of 3 key cases that we need to cover. Those 3 key cases include having a control case, which is a case which should always pass. It's something that we know the model handles well. It's unambiguous. The second is edge cases. And these are cases where we've seen the model fail before. And by including instructions into the prompt, we're making sure that same behavior doesn't slip through again in the future. And finally, and critically, we need to make sure that the model has a good understanding of the extent of its capabilities, where it should be handing off to a human, or where actually maybe it should be point blank refusing to answer a request. So in the example that we're going to be looking at today, we'll be using a prompt for a customer support bot for a telco company called Meridian Mobile. And these are the 5 test cases that we are going to be looking at today. We have a simple control case looking at what's the data limit in the basic plan. We're also looking at edge cases, such as its ability to do calculations, such as calculating proration bills. If I switch my bill halfway through the month, or if I switch my plan halfway through the month, what will my bill look like? We want to check that it's accurately addressing key questions which are covered by our policy. We need to make sure that it's escalating to a human whenever there is a billing error. And finally, we want to make sure that our model isn't withholding any information that it has access to, which it should be handing over to the customer. So what we're going to do in this process is we'll take our prompt and we'll run it on our V0 of the eval. And we'll see what our failure modes are and systematically target those failure modes one at a time to see if we can resolve those failure modes by prompting. And along the way, we'll learn a little bit more about the kind of anti-patterns and traps to avoid. And this is representative of how we would apply these best prompting techniques in practice, right? We are rarely writing a prompt from scratch. We're often debugging an existing prompt. And best practice before we start targeting those failure modes specifically is to kind of apply our general prompting 101 best practices, applying general hygiene to clean up before we do the eval run. So let's have a little look at the example that we're going to be using. So what we're looking at here, first of all, before we look at the prompt, is just this vibe-coded web app that I've made for the presentation today so that we can look at how we're iterating on the prompt together. In this page here, I can easily run my evals on all 5 test cases and inspect the results in a little bit more detail. So before we have a look at the prompt, I'm just going to run the evals in the background. This is a pretty good first pass at a prompt. When we look at this, we've defined the bot's role at the top. When we scroll down, we've given it some data. We've given it some information on how to reason over the answers that it should be giving to the customer. It's giving some critical instructions around the tone it should use, how to do calculations, etc. And then finally, we're passing in our customer account context and our user message. So let's have a look at how our first pass at the evals did. So we can see, as we expect, our control case, all of our test cases have passed. This is what we expect for this unambiguous test case. But it's performing pretty poorly in these other areas. Now, before we zoom in on those specific failure modes here, let's do some general cleanup of our prompt. So as we mentioned, when we look through this prompt, there's a couple oddities here already. So for example, the first one is we're telling the bot that it's a human, which just isn't true, right? We can see as we scroll down, there's clearly some information here that has been copied directly from a website. So the key giveaway here is a reference to a hero image. There's even some references to cookies at the bottom. So we need to remove a bit of redundant information. When we look at the instructions here, they're all grouped into one big paragraph. So we've got some reasoning here, we've got instructions about the role, some critical instructions as well, without a real way of unpacking policy from guidelines, from tone, etc. So let me just... I've preempted some changes we want to make to this prompt, and this is just a diff view of some of those changes. So what we've done is, first of all, added some structure. So you can see that we've added XML tags here to define the role, to separate general guidelines, to separate policy, to separate tone of voice, etc. So if we run that eval then on this new updated prompt, we should hopefully see an improvement in the output as is. So we can see just by clearing up the prompt, we've already improved the model's performance on this prepaid scenario. There's an interesting regression there in that fifth hotspot case, and I don't want to worry too much about that now. There's going to be some natural level of variance in the different runs of the eval, and we'll come back to that case specifically to see if we can make the prompt consistently better in that area. So what did we learn from this then? Simply clearing up the prompt with a better structure, with a better role description, has improved the performance. And this is a best practice that you can return to at any stage of writing and maintaining your prompts, especially as your prompts get more detailed and more complex. A general rule of thumb that I like to follow is if you're reading a prompt and you can't tell guidelines from policy, from data, most likely the model isn't able to either. So before looking at some of those cases in more detail, there's a little bit more general cleanup we can do, specifically here looking at creating an output contract. This is a key best practice to follow if you're struggling with your output format consistency. Now, in this case, we have a customer support bot. We want it to reply in a conversational tone, so it's unlikely to be a big issue in this case, but it's something to bear in mind if you're dealing with more complex output structures like nested JSONs, for example. So again, if we go back to the prompt and see what fixes we can apply here, first of all, we've added a section at the end where we've defined an output format for the model, telling it to use XML tags to output the response. But the prompt is not always the most effective way of handling issues. We can also change things in the harness to ensure consistency to a higher degree. So what we've added here to the API call is a stop sequence, which is going to detect that closing XML tag and tell the model to stop generating a response at that point. Now, when I run the eval here, I don't necessarily expect to see any clear improvement in performance, but it's a general best practice that we should be following, and as I said, is something that we should remember, in particular when we have more complex output schemas. One thing to point out here as well, if you do have a more complex output schema, something like structured outputs can be incredibly helpful to ensure that consistency in a more programmatic way. OK, so after the cleanup then, we can see that we now have 2 test cases which are consistently passing, but we have 3 key failure modes: the proration, the billing error, and the hotspot. So let's isolate these one by one to iterate on the prompt and see the effect of that. First of all, then, the hotspot question. So the question is how much hotspot data is on my unlimited plan. What we expect the model to do is state directly the amount of hotspot data that the customer has. And the reason this is a slightly complex case is because the customer test case that we're dealing with is on a legacy plan. So actually, the current policy doesn't apply to them. So if we see what's going on in the actual test case here, the customer data which we're feeding to the prompt includes the amount of hotspot data that customer has. They have 5 gigabytes, right? But they also have a grandfathered plan. So what we're seeing the model is actually telling the customer is the general, the unlimited plan includes 4 gigabytes, but since you're on a legacy plan, you should go check this out yourself. So let's have a look at the prompt then to see why the model is deflecting this question to the customer account URL rather than actually giving the information itself. Now, if we read this prompt, originally it said, we changed our plans recently, and the policy doc shows the current plan data and customers on grandfather's plan have different rates. Never give a customer the wrong plan details. Instead, point them to the URL. So it's clear that this instruction, this latter one, never give customer the wrong information, is the instruction that the bot has been optimizing for. And you might recognize this as being very similar to a patch that you might have introduced in a previous model that you were using to avoid, where the model was giving the customer the wrong information about their plan. Now, as our models have evolved, they have gotten much better at instruction following. So it's likely that instructions like these have now become redundant and are actually being overfitted to. So what we're going to tell the model instead is give this balanced view where it says, customers on grandfather's plan have different allowances, but it's captured in the customer information that's given, and that is the accurate source of truth. So running the eval here, we should hopefully be addressing all of the test cases for the hotspot case. Now, I am running this live, so there could be some variability here, but we see here that now clearly all of our test cases are passing. So what did we learn from this? Well, we worry a lot about hallucinations or the invention of facts and numbers, but actually the opposite can also happen. The model can withhold information that it actually has access to. Now, we saw here that this is likely a result of a patch that we introduced for a previous model, and a best practice that we could follow here is actually using version control, where wherever we are making defensive changes in the prompt, we are tracking the reason why we've introduced these. Sometimes they're necessary, but in the future, these kind of changes can produce unwanted effects so that we can backtrack on them. So the next failing test case then is this proration calculation where a customer asks, what if I upgrade to the 30 gigabyte plan? What will my next bill be? And what we want the model to do is to perform some calculation and return exactly what their next bill would be, rather than giving some sort of vague output, which is what we can see it's doing right now. If we look at what the model is returning, it's clearly reasoning through it. It's doing a little bit of mental maths here and there, but it's not really giving the customer a concrete answer, and I wouldn't rely on this as being able to accurately give the customer a response. So if we look at the prompt then to see how we can fix this, in the original prompt, we can see that all the instructions that were given to it is telling it, don't ever give a customer a vague answer. Critical, always calculate any prorated amounts correctly. Now, telling the model to do a good job isn't particularly helpful when we don't give the model the capability to actually do a good job. We want to avoid the model doing mental math. So what we're going to introduce is give the model a tool. So we're saying in the prompt, whenever you're doing any calculations, please use the calculate proration tool to do so. In order to introduce that tool, we need to introduce it into the API to tell the model you have access to this tool. We need to define the tool schema, which tells the model what this tool does and when to use it. And then finally, we need to actually implement the tool, which is the maths behind how it should be doing that calculation. So running that eval then for another pass. We can see that all the test cases are now passing. It's clearly done the maths using the tool in the background and returning the correct response. So the key lesson to take away here is instructions don't add capability. Telling the model it's critical to do a calculation right doesn't make it better at mental math. So the correct approach was to give it a tool, overall giving it the ability to reason over harder problems and using tools to actually execute them reliably. So now we have one final failing test case which we need to address, which is this billing error here. In this scenario, there is a billing conflict, and what we really want is the agent to escalate this to a human. And what we're seeing it doing instead is it's trying to explain to the customer what the reason behind it might be, and it's trying to kind of diagnose the problem itself. So in order to fix this behavior, let's again have a look what it was told in the prompt. We see in the initial instructions it was giving, it says, avoid escalating or transferring to a care specialist unless absolutely necessary, as it cost approximately $8 and it counts against our team's fast contract resolution. Now, this is only giving one side of the story, right? We're telling it what the cost is to escalating, but not the benefit, which means it's going to overfit again to not escalating this scenario. And second of all, we've got this clear conflict between what we've defined in the eval in terms of what we want the model to do this escalation versus what we're actually telling it to do. And the fix that's relevant here is to give it both sides of the story by saying it costs $8 to escalate a case, but actually, if you get this wrong, then it's going to cost you a refund as well as customer trust. Again, here we observed how the model optimizes for a goal, and this kind of instruction is a common instruction to give. It's quite similar to the one we saw earlier, where we didn't want it to overfit to a certain type of behavior. But it's the kind of instruction that can be followed quite differently by different generations of models. And specifically, as models become more intelligent, we need to remember to state both sides of the trade-offs, because our models are becoming better themselves at making those trade-offs themselves. So if we just go back to our eval then and run our final test case, we should see that all of our evals are now passing correctly. So overall, we looked at applying general hygiene principles, how that can provide an initial uplift to the prompt, making sure we're removing any redundant instructions which were initially intended as patches for previous models' behavior, making sure we're giving it tools to do certain tasks reliably. Now, there's one other scenario that we introduced at the start, which is one that you might also encounter in your work, which is where we're building a new agent from scratch. And the example that we'll look at here is an agent whose purpose it is to create a week-long retail staff schedule based on employee availability and other constraints. And when we're building a new agent from scratch, we need to consider not just the prompt, but also the model that we're using and the harness that we're using. So in this next example, we're going to compare a number of approaches to explore the impact of those three different areas. So again, I've just vibe-coded up this web app so that we can walk through this problem in this demo. Here I've just laid out what the problem is that we're addressing. We have our 8 employees. On the right, we have this schedule that we need to staff with the headcount, and we have our constraints that must be satisfied in every scenario. Now, because we have these hard rules, rather than using an LLM judge like we did in the previous case to do the grading, we can actually use just a Python function which programmatically checks for every schedule that's generated how many violations were made. So to begin with, we want to start simple. We're going to use a simple prompt. We're going to use the bare bones that we think we'll need with a model Sonnet 4.6 to see how it performs, and how we're going to hill climb against that. So here is our baseline prompt. We've already applied some of that general hygiene and those best practices that we saw earlier on, using XML tags to structure the prompt. We've given it an output format as well. Now that we're giving a schedule, we're asking it to output a JSON, which, if we don't give that output structure, might lead to parsing errors downstream. When we run the simple model on a first iteration of the evals, all cases fail. Now, just what we're looking at here is in our test set, we're essentially repeating, we're doing 5 trials here, and these numbers are showing how many violations were made in each trial. In the outputs, we can see that it's made a decent attempt at reasoning through the problem, but it's burning a lot of tokens, and it's clearly not checking its work as it's not getting to the right impact. So let's try a larger model, a model which we know is better at reasoning. So we're going to run it through Opus 4.7 instead, keeping everything else the same. Now, interestingly, whilst all test cases are still failing, you can see that the overall number of violations that Opus has made has reduced significantly from Sonnet 4.6. So we're possibly onto something here, right? This isn't good enough to ship because it's still failing, but clearly giving it more reasoning capability is helping drive it towards a better result. So what we're going to try next is using Opus with adaptive thinking instead. So it can decide for itself how much thinking it needs, how much reasoning it needs to use to solve this issue. So no change to the prompt, really just a change to the API here. So this now seems to reliably generate compliance schedules, but it requires a lot more tokens. We're tripling, essentially, in the number of tokens that we're using here, and we're tripling the latency. So we want to try and see if we can optimize that cost-latency trade-off a little bit more. This is latency 100 seconds. Obviously, I'm running this one async for the purposes of time. Opus 4.7 hasn't magically gotten much faster since the last time you used it. So let's see if we can optimize a little bit more for the token latency trade-off. What we haven't tried yet is using Sonnet 4.6, so a smaller model, but with a better prompt. We looked a lot at the prompt optimization in that last section. So I've added a couple details to the prompt here. We're in particular how to reason through this problem, and most critically, telling it to check its work before outputting it. So when I ran that eval, we see that it passes in 2 out of the 5 cases. Now, the failure modes that we're seeing is actually not violations of the scheduling requirements, but the model hasn't been able to finish the tasks within the output limit that we set. So whilst we could increase the max tokens that this model is able to use to get all 5 test cases passing, we see here that we're using even more tokens, and this run has an even higher latency. So this is probably not the route that we want to go down. Now, as a final pass then, we want to look at doing this a little bit more agentically. So we're going to use this generate, evaluate, repair loop, where essentially the generator now creates a first draft of the schedule. And then we have a separate prompt which reports any specific violations that it made. So not programmatically checking it, but checking it with an LLM. So we're checking for every rule, and we're providing evidence of every violation. And we then have a third repair prompt, which receives any violations that were made and tries to make targeted fixes to it. So we have three very simple prompts, but they're now running independently rather than trying to do everything in one large prompt. So we can see in this case our agentic approach has solved all of our test cases with a much lower number of tokens and with a lower latency than trying Sonnet 4.6 with a better prompt. So going forward, it seems like there's two appropriate approaches to take here. Using Opus 4.7 with adaptive thinking or using this agentic loop. Now, moving forward, we'd probably want to do a little bit more optimization on this loop to try and get it to be more efficient. But there's one key benefit as well from using this generate, evaluate, repair loop. And that is that you can put in soft requirements at runtime. So in the evaluation prompt, we can say, Harry doesn't like working with Sally, so as much as possible, try and separate them from working together. Or we need a third shift on Wednesday, for example. So it means that you're not having to make changes to the Python function, which is doing the evaluation in the back end every time to satisfy for any soft constraints, which might depend just on a case-by-case basis. So to wrap up then, pulling all of those learnings together, what did we see? Well, we looked at two scenarios which I as an engineer see most in my day-to-day, which is where we're maintaining a prompt, we're migrating to a new model which has some different behaviors, and building a new use case from scratch. We saw that general hygiene principles, following those can immediately uplift the performance against a set of evals, and that we need those evals to be able to rigorously see any impacts of changing our prompt on the output. Then we saw this process of targeting failure modes one by one, adding structure, avoiding long ban lists, etc., were all things that helped push our model to the correct behavior. And then finally, with our new agentic bot that we were building, we saw the impact of splitting into three separate prompt systems. So rather than using one prompt to address everything, we're actually isolating different tasks where it's easy and repeatable to separate out the steps that it needs to take every time. Thank you so much for attending this afternoon. I hope you have a fantastic rest of your day.
How is everybody? A little bit more than that. Come on, guys. How is everybody? Thank you. Thank you. So I'm Dan Carey. I am a product manager. I lead a product within Anthropic Labs. Today, we're going to talk a little bit about Claude Design. Can I get a quick show of hands? Who here has already tried Claude Design? OK, great. For those of you who haven't had a chance yet, Claude Design, it's a new product from Anthropic Labs, and it lets you collaborate with Claude to create polished visual artifacts. These can be designs, prototypes, slide, one-pagers, more. Right? You can do a lot of different things with this product. And as of, I think it's yesterday, the product's been live in research preview for 1 month. So we're pretty happy about that. Today, I'm going to tell you a little bit about how a very small team, it was 3 people for most of the development, built Claude Design in about 10 weeks from idea to launching the product. And the reason I'm going to share these things with you is because the most common question I get asked is, why did you decide to start working on this? How did you see that this was an opportunity for building a new AI-enabled product? How'd you build it? How'd you launch it? So everything I'm going to cover here, there's no real secret sauce. These are all things that work well for us. Take what you like. You can do a lot of these things tomorrow. To start, I want to tell you about what Anthropic Labs is. It's kind of funny. It's a lab inside a frontier lab. We don't have any labs within Anthropic Labs, but it is labs quite a ways down. The way that we usually talk about it is as a bet factory. And by that, I mean we have very small teams exploring the frontier of what the models can do and making bets about whether or not something will work. We run experiments to find out what works. We double down on the things that are working. We fold the things that are not working. And at any given time, we might have a dozen small teams exploring different concepts. So it's lots of exploration, small number of really high conviction releases of things that we think can be moonshots or change how people work with the models. There's a few products that came from here that you may know. Claude Code came out of labs, Design came out of labs, MCP came out of labs, Skills came out of labs. We had the Claude and Chrome extension. We had our work on hands-free audio come out of labs. So this is a process that's worked pretty well for us, and we just keep turning the crank on this. If you look at how each of our bets operate on a day-to-day basis, you're going to see a lot of parallels with lean startup methodologies. Nothing there is rocket science. We did not invent any of these things. I'd say the biggest difference is the speed at which we run our loops. We spend time with users and also Anthropic researchers every single day. My favorite thing to talk to users about is, please complain at me. And my favorite thing to talk to researchers about is, what have you been surprised by lately? Because both things are often opportunities for new bets, new products, new things to explore that could pay off for us. We also aim to ship to users every day or two, right? We're trying to ship something new every single day in response to what we hear from people. We are trying to keep a very, very high cadence of innovation on the team, and we are trying to get things out based off of what people tell us. Likewise, when people tell us something's not working, or they have feedback, or they have a suggestion, early on in a project, we try to ship them the response to that the next day. Oftentimes, we're able to do the same day. Sometimes it's the next day. Not everything hits that bar, but our usual goal is to get things out very quickly to people when they have feedback. Finally, we do not try to predict the future. A lot of labs groups out there do try to predict the future. They say, in 10 years' time, we're going to have this amazing technology, and it's going to do these amazing things. We don't do that. Instead, we try to ship. We watch people use the stuff. We learn what they do. We ship. We watch. We learn. We ship. We watch. We learn. We just run that loop over and over. And so for Claude Design, we ran that loop somewhere between 50 and 100 times over the course of those 10 weeks. So why did we start working on Claude Design? Well, we started working on Claude Design because Claude Code made engineers really, really fast. And the rest of us had to keep up. So product development timelines, they used to be 6 months. And then they'd be a month. And then a week. And now a day. So sometimes things that you were spending a week on before are now something that you're getting done in a couple hours and getting out in front of users. That is rapid. Can I see a very quick show of fingers from people? I'm very curious. The last feature you shipped, how many weeks did it take from idea to getting it in front of users? It's okay if you need 2 hands, and don't be shy here. 1, 1, 10, 1, 2, 1, 4, 1. A lot of different answers, but things have gotten a lot faster. Think about what your answer would have been a year ago, right? All these timelines have compressed a lot. And so once Claude Code took off, the bottleneck moved. The bottleneck moved from building the feature to figuring out the right things to be building for your users in a lot of cases. So the option was either skip those early steps, just try and decide on the fly, and potentially build the wrong thing really fast, or try to find ways for the rest of us to speed up. So our designers, our PMs were having trouble keeping up. We needed our own acceleratory tool. And somebody on our team, Nate, he was a designer on Claude Code previously. He had seen firsthand what happens when some of these teams speed up to such a huge extent. And that got him thinking about the problem and a potential solution. And so he ended up hacking together a prototype over the course of a weekend while he was working on a different bet. And it was very simple. It was the Agent SDK. It was a very thin IDE wrapper, and it used an existing skill that he had already been using in Claude Code. And this is how a lot of our labs bets start. It's one person, one weekend, one screen recording, someone gets something, hacks something together, and just shares what they did. So for us, Nate posts this in Slack. We run a lot of things in Slack. And everybody helpfully chimed in with both, this is what's promising about this, and also here's all the stuff that doesn't work, totally broken, please go fix. And that was his roadmap for the first couple weeks on this. It was just, what's the promising stuff to lean into? What are the major blockers we want to address? I do think it's worth calling out the things that we did not do. So we did not write a PRD in advance. We had 0 vision docs. We had 0 OKR meetings. We did not have an H1 annual staffing plan. We did not have a 2-pager for what we were going to do over the next 2 years. We did not write the press release in advance for what we were doing. Those things are great if you know exactly what you're building. We did not know exactly what we were building. All we knew is that we had a Spark. So who here works off of PRDs or has written one or worked off of one in the last month? Most of the room. Now, of those people that raised your hand, who would rather be working off of a prototype that worked and showed you the feature fully? Exact same hands, which is pretty good. So we like to use prototypes because documents are imprecise. It's so easy for 2 people to look at the same doc and have 2 different products in mind about what the experience should be. And usually those 2 ideas are not the same idea that the author had when they were writing the thing in the first place, right? So docs are imprecise. Prototypes, they're more concrete. They're more visceral. They let you get hands-on with the thing and really feel the experience yourself. And over the course of this project, we were able to get our prototyping cycle down to a couple of minutes, right? So if somebody had an idea, they were able to prototype and get it out in a couple of minutes. For us, the easiest way of doing this is talk to it with somebody else on your team, record it, transcribe it. There's tons of great tools for that. And mainly talk about what the problem is, what does the solution generally do, why do you care about solving this problem? And then we would take that transcript and we would just give it to Claude Design once we had something working, and we would say, give me a few options for this. This has effectively replaced PRDs for me as a product manager that's been writing them for almost 2 decades now. Now I just do prototypes. This is my flow. It works pretty well. In labs, we do this ritual every once in a while. We get together and we call them pitch-offs. And the thing I like doing about these is we all get together, we brainstorm. You're basically trying to nerd snipe other people to come work on your thing with you that you think the team should do. And when we first started doing these, people talk, and you just talk and present your thing, and it's not that compelling. The first time we did this with Claude Design is what convinced me that we had a promising product on our hands. Because in these pitch-offs, most of the ideas people come up with during the pitch-off. Someone says something and you're inspired by what they say, right? Somebody has an idea that you fork off of and you come up with something new on your own. And by the second half of it, 100% of the pitches were prototypes or slides made with Claude Design. And they were being made on the fly in the meeting. And that's what really convinced us, this is a proof point, we should double down on this bet. We should take this to market. The other thing that's a little bit different about the way that teams work in labs is the size of the teams. So almost every labs bet, it starts as a single person. It's just one person with their good buddy Claude exploring a really hard problem and exploring a pretty hard idea. And at this point, you are not trying to build the best product in the world. You are just looking for that little moment of magic. You are looking for that little hint of heat. You are looking for, hey, this is a promising idea because there is a little sparkly glimmer here that we can build into something compelling. And most labs bets, I'll admit, do not make it past this point. Most things we end up folding before they get here. And that's totally okay. This early exploration is usually hours or a few days for most things. Once we do have a promising spark, we usually scale the team up massively, 300%, all the way to 3 people. So these are not big teams. And the reason why we do that is that we want it to be a very tight group exploring together with very little collaboration overhead. If something is so compelling that we're pretty convinced that we're going to be taking it to a product, after it's had 3 people for a while, we might scale it all the way up to 5 people ahead of launch. So who here works on a team that is smaller than 20 people? Okay, almost everybody, but not everybody. What about smaller than 10? 5? Smaller than 3? Is there anyone here that's totally solo? Oh yeah, a couple people. 3-ish, 2.5, 4. Okay. So for most of Claude's Design's development, it was only 3 people with Claude and Luckily, Claude's a pretty good team member. So what makes that possible? I'm sure this is also true of a lot of these solo builders in this room. Everyone on the team does everything, right? The engineers talk to users, PMs write code, designers do data analysis. All of these things are enabled in part with Claude. And the lines between the roles on this team, they have essentially dissolved at this point. You do have your specialization, you do have the unique perspective and diversity that you bring to a team, but at any moment, any one of these people on this team can talk to 10 users, you can realize what the underlying problem is, you can design a solution to it, you can ship it to users, you can listen for feedback, you can keep iterating solo if you need to. And quite often that's the case. That's how most features happen. Most things on the team are totally solo. And having this small team where everyone can do everything, that's the main thing that minimizes coordination overhead for us. Again, most things can be done solo, but let's say you have to get the whole team together. Oftentimes that's as easy as talking to the person on your left and the person on your right, and you're done, right? It's not a big alignment meeting. It's not something you have to schedule. It's not something that you have to wait for. And so this helps us minimize coordination overhead. We've already minimized planning and process just by relying on prototypes. And just doing these two things alone would let us go pretty quickly, right? They would let us go pretty fast. They would take down these big, long cycles at the beginning of major milestones. But we go a good bit faster, and we go a good bit faster by then really aggressively optimizing every single other step in our development process, in our loop. So our loop is our loop. This may not be the right loop for you. That's not the message here. If you're working on hardware, this is probably the wrong loop. But our loop is pretty basic. We talk to users, we design features, we ship code, we read feedback, and then we do it again. And again, we're just trying to do this over and over and over and over. And the point's not the specific loop, it's not the specific interventions that we did here. It's rather the thought process that goes into these is, why are you doing this work that Claude could do for you a lot of times? Or why haven't you built your own tooling? Because every little bit of optimization that you do on your loop is going to pay you back if you're running it 50 to 100 times in a project. So for a really simple example, I mentioned that we talk to users every day. We want that to be the easiest thing in the world. We are people, we do things that are easy. We tend to do things that are hard less often. And so we want the easiest thing in the world for us to be to talk to users. And so we did the really basic stuff from the beginning. We create shared Slack channels with anyone using the product. We do a ton of internal dog fooding. We talk to our dog fooders all the time with new features. But then we sped this up by bringing Claude into all of those conversations. So Claude looks at all of our customer conversations. It looks for commonalities across conversations, because you and I may be talking to different users today who may have the same suggestion. We want Claude to tell us that if we don't talk. We do it for early analysis. We do it for early investigation. We have Claude do the first look at all of this stuff for us. We're the ones having the conversation. We don't put Claude between us and the users in that case, but we do have it do all of the analysis that we were already doing on every other conversation as an immediate follow-up. So talking to users, most important thing, obviously we want to optimize it. Our next thing on here was designing features. And luckily we have a great product for that now. When we got started, we did not have the tool that we wanted for designing features. Our team, we would use Claude Code, we would build prototypes with it, and then when it came time to share that prototype, I would either record a video, or we would put up a branch and say, pull down this branch and try it, or you would just commit it into a sandbox and let other people pull it down and try it. So we wanted to use Claude Design to design Claude Design, and so very quickly, Claude Design got great at designing Claude Design, which is fantastic. I have to say, if you do any developer tool, if you're using your own developer tool to improve your developer tool, it's the best situation in the world. It makes things so much easier. There's a lot of other features that you see in Claude Design today, from the way it explores code bases, the way it links with GitHub. Even multiplayer was something that we built based off of how we were working in Claude Design to design Claude Design. For multiplayer, we were getting to these scenarios where I might prototype something and then share it with somebody else on the team. They would take a look at it, and then they would tell me what they thought we should change about it, and I would hands-on keyboard type it in, and then we would look at what it was. We wanted to take that step out And so we just made it possible for multiple people to be iterating on the same design at the same time. We had originally built that for ourselves to go faster, and then as soon as we brought the product over to users, the very first request was, can I use this with the rest of the people on my team in real time? So we made a first-class part of the product. The next thing that we've done in here is we wanted to optimize how we ship code. So if you've used Claude Design, you have probably used the handoff to Claude Code. It's fantastic. It's such a good way of getting your designs into production. And that's another feature that we built really to speed up our own workflow. When we started out, we would design our features, and then we would export all the files, and then we would import them into Claude Code, and then we would retype all of the context that we had done over multiple turns of conversation with Claude Design so that Claude Code would have all that context. And that was slow. We didn't like it being slow, right? So we wanted to improve it. And so we originally built this for ourselves, and then as soon as we started handing off the product to other people, the first request was, great, now how do I get this into production? So first was multiplayer, and then right after was, okay, now that I have the thing, I want to actually ship it. And so this was another spot where we just had too much friction. We're working for ourselves, we're optimizing for ourselves to get it out there. The last step in our iteration cycle is to read feedback, right? At this point, we get too much feedback for one person to read through all of it. I think that would be a full-time job. But we still want to make sure that we don't miss anything. And even if we had that one person whose full-time job was to read that feedback, we would probably miss things. And we would miss things because the number of small issues that pop up, you don't want to miss them. It's too much for any one person to keep in their head. So to deal with that scale, we ended up building our own feedback clustering tool. It took an afternoon. It wasn't something that we were going to wait on. We needed to have this. And so right away, we ended up building this. We rolled this out. And now we have Claude taking a look at all feedback that comes in. It tries to match it up with system monitors, with system traces. It tries to look for common trends across things. It does initial analysis if things look like a bug. We have tried to make all of those initial steps that we would do looking at that feedback automatic to speed ourselves up. So we also found ourselves, we would take everything it said, and then we would have to come up with a suggestion after reading through all of that. So now we have Claude give us a suggestion on how to fix it, and then we found ourselves copying and pasting. And so we just made that a button to bring it directly over into our development tooling. So not everything we built worked, right? Just because you're really fast doesn't mean you're always really right. And we got tons of things wrong as we were building the product. So I want to tell you about one specific time where we got this wrong, and that was we started out early on, and we built these really advanced controls. These gave you really fine control over every single pixel. You could do anything with these. These were for power users. And in our early testers, we had a few power users who were very vocal, gave great feedback, and they loved this feature, right? They loved this set of tools. And we thought, great, we have something good on our hands. All the feedback that we're hearing looks great. But then as we dug into the usage, we found that everybody else hated them. Like, didn't just dislike them. People hated them. They were confusing. They were actively harmful to the product. And so we ripped them out. For us, this took a grand total of 1 week. So yes, we got off track, but from idea to course correcting and ripping out the feature and going on to the next thing took us about a week of time. Now, if we had been doing, a quarterly development cycle, and we had planned this to do this over a quarter, we would have been off track for an entire quarter. That would have been really bad for the product, given that the entire product shipped in less than a quarter. And so for us, it's not necessarily can you always go fast, it's can you always iterate in a small enough cycle that you're able to very quickly find out when you're wrong. This comes back to the run experiments bullet from earlier. So this taught us a couple things. One, this taught us that we should be a tool that lifts the level of craft for everybody, not just the ceiling on power users. It also taught us that we want to be as open as possible, because there will be users that we never meet the full needs of, right? There's going to be some power out user out there who wants to do something very specific that we're not going to support. And that's what convinced us that we want this to be a very open tool. That's why if you export from it, you get HTML, CSS, JavaScript. That's why we're trying to do more and more integrations that you can take things directly into other tools. We haven't talked about this publicly before, but I think this week or next week, we're going to be pushing out the ability for any design tool to integrate with Claude Code. Claude Design, just via their existing MCPs. So we want this to be a tool where you are able to explore. It lists the level of capability for everyone, and then the people that do have very specialized needs, if they have a tool of choice, they can just take their designs right into them. They're yours. So this slide's fun. On the left is that first prototype. It's a terminal and a browser, and that's about it. It's not the shiniest thing in the world. This is the level of those early explorations where all you're looking for is that little bit of promise, right? This is not obviously the final product that launched. On the right is the final product that launched. And there's a lot that separates them. And I'll admit this one on the left, it does have a little bit of promise in it. But 99% of the value came from those 10 weeks of iterating and shipping and talking to users every single day. The value came from the experimentation, figuring out what the right thing was to build, rather than knowing in advance this is exactly what we are going to be doing. So to put the amount of iteration this team does in perspective, Claude Design is shipped on a Friday, and by the following Monday, we had shipped 62 improvements to the product. That's a good number given that size of that team that we talked about earlier. And we made the product more token efficient. We improved its ability to handle images. We made it better at exploring code bases. We made most exports instant. It's a pretty long list, and it was all based off of user feedback that we got on launch day. Now, this was not a Herculean effort. This was not something that required all-nighters from everybody. This was something that was very natural, because the team had built up the processes and the muscles and the practice of doing this every single day for 10 weeks prior, right? This became a very quick, very normal way of working for us. I mentioned earlier that Claude Design has now been live for 1 month. And so also you may have seen this, but last night we just doubled token limits for the product. So one of the pieces of feedback that we heard was that people liked it, they wanted to use it more, so we're making that easier. So that's across all subscription plans. Before we close, I want to share one of the more counterintuitive things we've learned working in labs, and that is that you do not want to work on the thing that already works. You often want to prototype the thing that almost works. And the reason why you do that is because the models are improving so rapidly. The level of intelligence keeps going up. And the next model may just fix the issues that you cannot solve via engineering. We had this with Claude Design. There were a bunch of issues in that early prototype that we did not solve. We did not fix them with clever engineering. We did not fix them with amazing insights. We fixed them with Opus 4.7 coming out. And that's going to be true of a lot of things that everyone in this room, that we all work on together, right? The model releases are a tide that lifts all boats. They do a lot for you. So remember, early on, you're just looking for that hint of magic. You're not looking for something that works in full, that works completely, that handles every edge case. You're looking for something that could become that in the future. And so that's why when you find it, you want to start exploring, start building, start bringing it in front of users and figuring out the shape of the product that works. Because the shape's the most important thing, and it's the thing that we all get wrong when we first start. We all have to iterate on it. So there's 3 concrete things that you can try tomorrow from this talk if you want, if there's nothing else that you took away from it. The first is go ahead, next time you're going to write a PRD, skip it, right? Don't write it. Instead, just talk with Claude, talk with somebody on your team and take the transcript, and don't talk about specifically what the feature is, what buttons there are. Instead, just spend time talking about why you're trying to solve this problem. What are the characteristics of a good solution? And give that to Claude Design, give that to Claude, ask it to give you 3 variations on a prototype that might solve that. See if that works for you. The second, pick something that you've been waiting for. It could be feedback clustering like we did. It could be a new analysis tool, and just build it one afternoon. Everyone waits on tools when at this point, internal tooling, building your own stuff is rapid. It's very fast. So go ahead, scratch your own itch. You will be happy that you did. It will pay itself off very quickly. The third, and this one looks simple, but I think this is actually the hardest, take one real feature request. I don't mean like a small bug fix or a padding change. Take one real feature request from a user and turn it around in 24 hours, get the idea in front of them and follow up with them for feedback. And the reason why I bring that up is not this urge to go faster. It's because the first time you do this, if you're not doing this already, you are going to find that there are a bunch of roadblocks in your existing process and the existing way that you build software if you've been on a longer timeline. And that could be everything from the way that you do deploys, the way that you ask somebody on your team to review your code. That could be a whole host of things. So going through this once really helps. And I wouldn't try to do all three of these at once. I would layer these on. Each one is going to teach you something a little bit different that helps you move a little bit faster. This is the last show of hands, I promise. Who's going to try number 1? A lot. 2? 3? Okay. Thank you so much. That's the talk. Thank you for your time. I'd love to talk to folks who have used the product or even those that haven't. I'm going to be by the demo booth for most of the day for Claude Design. It's down at the end of the hallway. So please come find me, tap me on my shoulder, come complain to me, or tell me what surprised you. I'd love that. So thank you so much.
Hi everyone, thank you for joining us today for Prompting 101. My name is Hannah, I'm part of the Applied AI team here at Anthropic, and with me is Christian, also part of the Applied AI team. And what we're going to do today is take you through a little bit of prompting best practices, and we're going to use a real-world scenario and build up a prompt together. So a little bit about what prompt engineering is. Prompt engineering, you're all probably a little bit familiar with this. This is the way that we communicate with a language model and try to get it to do what we want. So this is the practice of writing clear instructions for the model, giving the model the context that it needs to complete the task, and thinking through how we want to arrange that information in order to get the best result. So there's a lot of detail here, a lot of different ways you might want to think about building out a prompt. And as always, the best way to learn this is just to practice doing it. So today we're going to go through a hands-on scenario. We're going to use an example inspired by a real customer that we worked with. So we've modified what the actual customer asked us to do, but this is a really interesting case of trying to analyze some images and get factual information out of the images and have Claude make a judgment about what content it finds there. And I actually do not speak the language that this content is in, but luckily Christian and Claude both do. So I'm going to pass it over to Christian to talk about the scenario and the content.
So for this example that we have here, it's intended, so to set the stage, imagine you're working for a Swedish insurance company and you deal with car insurance claims on a daily manner. And the purpose of this is that you have two pieces of information. We're going to these in detail as well, but visually you can see on the left-hand side we have a car accident report form, just detailing out what transpired before the accident actually took place. And then finally we have a sort of human-drawn sketch of how the accident took place as well. So these two pieces of information is what we're going to try to pass on to Claude. And to begin with, we could just take these two and throw them into the console and just see what happens. So if we transition over to the console as well, we can actually do this in a real manner. And in this case here, you can see we have our shiny, beautiful Anthropic console. We're using the new Claude 4 solid model as well. In this case, setting temperature to 0 and having a huge max token budget as well is just helping us make sure that there's no limitations to what Claude can do. In this case, you can see I have a very simple prompt, just setting the stage of what Claude's supposed to do. In this case, mentioning that this is intended to review an accident report form, and eventually also determine what happened in an accident and who's at fault. So you can see here with this very simple prompt, if I just run this, let me go to preview, we can see here that Claude thinks that this is in relation to a skiing accident that happened on a street called Köpmangatan. It's a very common street in Sweden. And in many ways, you can sort of understand this as a mistake in the sense that in our prompt, we actually haven't done anything to set the stage on what is actually taking place here. So this sort of first guess is not too bad, but we still know there's a lot of intuition that we can bake into Claude. So if we switch back to the slides, you can see here that in many ways, prompt engineering is a very iterative, empirical science. In this case here, we could almost have a test case where Claude is supposed to make sure it understands it's in a car or a vehicular environment, nothing to do with skiing, and in that way you iteratively build upon your prompt to make sure it's actually tackling the problem you're intending to solve. And to do so, we'll go through some best practices of how we at Anthropic break this down internally, and how we recommend others to do so as well.
So we're going to talk about some best practices for developing a great prompt. First, we want to talk a little bit about what a great prompt structure looks like. So you might be familiar with kind of interacting with a chatbot, with Claude, going back and forth, having a more kind of conversational style interaction. When we're working with a task like this, we're probably using the API, and we kind of want to send one single message to Claude and have it nail the task the first time around without needing to kind of move back and forth. So the kind of structure that we recommend is setting the task description up front. So telling Claude, what are you here to do? What's your role? What task are you trying to accomplish today? Then we provide content. So in this case, it's the images that Christian was showing, the form and the drawing of the accident and how they occurred. That's our dynamic content. This might also be something you're retrieving from another system, depending on what your use case is. We're going to give some detailed instructions to Claude, so almost like a step-by-step list of how we want Claude to go through the task and how we want it to tackle the reasoning. We may give some examples to Claude. Here's an example of some piece of content you might receive. Here's how you should respond when given that content. And at the end, we usually recommend repeating anything that's really important for Claude to understand about this task. Kind of reviewing the information with Claude, emphasizing things that are extra critical, and then telling Claude, OK, go ahead and do your work. So here's another view. This has a little bit more detail, a little bit more of a breakdown. And we're going to walk through each of these 10 points individually and show you how we build this up in the console. So the first couple things, Christian's going to talk about the task context and the tone context.
Perfect. So yeah, if we begin with the task context, as you realized when I went through a little demo there, we didn't have much elaborating what scenario Claude was actually working within. And because of that, you can also tell that Claude doesn't necessarily needs to guess a lot more on what you actually want from it. So in our case, we really want to break that down, make sure we can give more clear-cut instructions, and also make sure we understand what's the task that we're asking Claude to do. Secondly as well, we'll also make sure we add a little bit of tone into it all. Key thing here is we want Claude to stay factual and to stay confident. So if Claude can't understand what it's looking at, we don't want it to guess and just sort of mislead us. We want to make sure that any assessment, and in our case, we want to make sure that we can understand who's at fault here. We want to make sure that assessment is as clear and as confident as possible. If not, we're sort of losing track of what we're doing. So if we transition back to the console, we can jump to a V2 that we have here. So I'll just navigate to V2. And you can see here, I'll also just illustrate the data, because we didn't really do that last time around, just to really highlight what we're looking at. So what we're seeing here, this is the car accident report form. And it's just 17 different checkboxes going through what actually happened. You can see there's a vehicle A and vehicle B, both on the left and right-hand side. And the main purpose of this is that we want to make sure that Claude can understand this manually generated data to assess what's actually going on. And that is corroborated by, if I navigate back here, to the sketch that we can highlight here as well. In this case, the form is just a different data point for the same scenario. And in this case here, we want to bake in more of the information into our version 2. And by doing so, I'm actually elaborating a lot more on what's going on. So you can see here I'm specifying that this AI system is supposed to help a human's claims adjuster that's reviewing car accident report forms in Swedish as well. You can see here that we're also elaborating that there's a human-drawn sketch of the incident, and that you should not make an assessment if it's not actually fully confident. And that's really key, because if we run this, you'll see that, and you can see it's the same settings as well, Claude 4, our new shiny model, 0 temperature as well. If we run this, we can see here what actually happens. In this case, Claude's able to pick up that now it's relating to car accidents, not skiing accidents, which is great. We can see it's able to pick up that vehicle A was marked on checkbox 1, and then vehicle B was on 12. And if we scroll down, though, we can still tell that there's some information missing for Claude to make a fully confident determination of who's at fault here. And this is great. This is pertaining to your task that you have set. Make sure you don't make any claims that aren't factual, and make sure you only sort of assess things when you're confident. But there's a lot of information we're still missing here regarding the form, what the form actually entails, and a lot of that information is what we want to bake into this LLM application as well. And the best way of doing so is actually adding it to the system prompt. which Hannah will elaborate on.
So back in the slides, we have the next item we're going to add to the prompt. And this is background detail, data, documents, and images. And here, as Christian was saying, we actually know a lot about this form. The form is going to be the same every single time. The form will never change. And so this is a really great type of information to provide to Claude, to tell Claude, here's the structure of the form you'll be looking at. We know that will not ever alter between different queries. The way the form is filled out will change, but the form itself is not going to change. And so this is a great type of information to put into the system prompt. Also a great thing to use prompt caching for. If you're considering using prompt caching, this will always be the same. And what this will help Claude do is spend less time trying to figure out what the form is the first time it sees the form each time. And it's going to do a better job of reading the form because it already knows what to expect there. So another thing I want to touch on here is how we like to organize information in prompts. So Claude really loves structure, loves organization. That's why we recommend following kind of a standard structure in your prompts. And there's a couple other tools you can use to help Claude understand the information better. I also just want to mention all of this is in our docs with a lot of really great examples. So definitely take pictures, but if you forget to take a picture, don't worry. All of this content is online with lots of examples, and definitely encourage you guys to check it out there too. Anyway, so some things you can use, delimiters like XML tags. Also Markdown is pretty useful to Claude, but XML tags are nice because you can actually specify what's inside those tags. So we can tell Claude, here's user preferences. Now you're going to read some content, and these XML tags are letting you know that everything wrapped in those tags is related to the user's preferences. And it helps Claude refer back to that information, maybe at later points in the prompt. So I want to show back in the console how we actually do this in this case. And Christian's going to pull up our version 3. So we're keeping everything about the other part of the user prompt the same. And we've decided, in this case, to put this information in the system prompt. You could try this different ways. We're doing it in the system prompt here. And we're going to tell Claude everything it needs to know about this form. So this is a Swedish car accident form. The form will be in Swedish. It'll have this title. It'll have 2 columns. The columns represent different vehicles. We'll tell Claude about each of the 17 rows and what they mean. You might have noticed when we ran it before, Claude was reading individually each of the lines to understand what they are. We can provide all of that information up front. And we're also going to give Claude a little bit of information about how this form should be filled out. This is also really useful for Claude. We can tell it things like, humans are filling this form out, basically. So it's not going to be perfect. People might put a circle. They might scribble. They might not put an X in the box. There could be many types of markings that you need to look for when you're reading this form. We can also give Claude a little bit of information about how to interpret this or what the purpose or meaning of this form is. And all of this is context that is hopefully really going to help Claude do a better job analyzing the form. So if we run it, everything else is still the same. So we've kept the same user prompt down here. Oh, your scroll is backwards from mine. You have the same user prompt here, still asking Claude to do the same task, same context. And we'll see here that it's spending less time. It's kind of narrating to us a little bit less about what the form is because it already knows what that is. And it's not concerned with kind of bringing us that information back. It's going to give us a whole list of what it found to be checked, what the sketch shows. And here, Claude is now becoming much more confident. With this additional context that we gave to Claude, Claude now feels it's appropriate to say, vehicle B was at fault in this case, based on this drawing and based on this sketch. So already we're seeing some improvement in the way Claude is analyzing these. I think we could probably all agree if we looked at the drawing and at the list that vehicle B is at fault. So we'd like to see that. So we're going to go back to the slides and talk about a couple of other items that we're not really using in this prompt, but can be really helpful to building up your prompt and making it work better.
Exactly. I think one thing that we really highlight is examples. I think examples or few shot is a mechanism that really is powerful in steering Claude. So you can imagine this in quite a non-trivial way as well. So imagine you have scenarios, situations, even in this case, concrete accidents that have happened that are tricky for Claude to get right, but you, with your human intuition and your sort of human label data, is able to actually get to the right conclusion. Then you can bake that information into the system prompt itself by having clear-cut examples of the data that it's supposed to look at, so you can have visual examples. You can use base64 encode an image and have that as part of the data that you're passing along into the examples. And then on top of that, you can have the sort of depiction or description rather of how to break that down and understand it. This is something we really highlight and emphasize in how you can sort of push the limits of your LLM application is by baking in these examples into system prompt. And this again is sort of the empirical science of prompt engineering, is that you sort of always want to push the limits of your application and get that feedback loop in where it's going wrong and try to add that into system prompt so that next time when example that sort of mimics that takes place, it's able to actually reference it in its example set. You can see here as well, this is just a little example of how we do this. Again, really emphasizing the sort of XML structure that we enjoy. It gives a lot of structure to Claude. It's what it's been fine-tuned on as well. And it works perfectly well for this example. And in our case, we're not doing this just because it's a simple demo, but you can realistically imagine if you were building this for an insurance company, you would have tens, maybe even hundreds of examples that are quite difficult, maybe in the gray, that you'd like to make sure that Claude actually has some basis in to make the verdict next time. Another topic we really want to highlight, which we're not doing in this demo, is conversation history. It's in the same vein as examples. We use this to make sure that enough context-rich information is at Claude's disposal when Claude's working on your behalf. In our case now, this isn't really a user-facing LLM application. It's more something happening in the background. You can imagine for this insurance company, they have this automated system, some data is generated out of this, and then you might have a human in the loop towards the end. If you were to build something much more user-facing, where you'd have a long conversation history that would be relevant to bring in, this is a perfect place in the system prompt to include because it enriches the context that Claude works within. In our case, we haven't done so, but what we do is, and the next step is try to make sure we give a concrete reminder of the task at hand.
So now we're going to build out the final part of this prompt for Claude, and that's coming back to the reminder of what the immediate task is and giving Claude a reminder about any important guidelines that we want it to follow. Some reasons that we may do this are A, preventing hallucinations. So we want Claude to not invent details that it's not finding in this prompt, right? Or not finding in the data. If Claude can't tell which form is checked, we don't want Claude to take its best guess or invent the idea that a box might be checked when it's not. If the sketch is unintelligible, the person did a really bad job drawing this drawing, and even a human would not be able to figure it out, we want Claude to be able to say that. And so these are some of the things we'll include in this final reminder and kind of wrap-up step for Claude. Remind it to do things like answer only if it's very confident. We could even ask it to refer back to what it has seen in the form anytime it's making a factual claim. So if it wants to say vehicle B turned right, it should say, I know this based on the fact that box 2 is clearly checked, or whatever it might be. We can kind of give Claude some guidelines about that. So if we go back to the console, we can see the next version of the prompt. And we're going to keep everything the same here in the system prompt. So we're not changing any of that background context that we gave to Claude about the form, about how it's going to fill everything out. We're not changing anything else about the context and the role. We're just adding this detailed list of tasks. And this is how we want Claude to go about analyzing this. And a really key thing that we found here as we were building this demo and when we were working on the customer example is that the order in which Claude analyzes this information is very important. And this is analogous to the way you might think about doing this if you were a human. You would probably not look at the drawing first and try to understand what was going on, right? It's pretty unclear. It's a bunch of boxes and lines. We don't really know what that drawing is supposed to mean without any additional context. But if we have the form, and we can read the form first and understand that we're talking about a car accident, and that we're seeing some checkboxes that indicate what vehicles we're doing at certain times, then we know a little bit more about how to understand what might be in the drawing. And so that's the kind of detail that we're going to give Claude here, is to say, hey, first, go look at the form. Look at it very carefully. Make sure you can tell what boxes are checked. Make sure you're not missing anything here. Make a list for yourself of what you see in that, and then move on to the sketch. So after you've kind of confidently gotten information out of the form and you can say what's factually true, then you can go on and think about what you can gain from that sketch, keeping in mind your understanding of the accident so far. So whatever you've learned from the form, you're trying to match that up with the sketch. And that's how you're going to arrive at your final your final assessment of the form. And we'll run it. And here you can see one behavior that this produced for Claude. Because I told it to very carefully examine the form, it's showing me its work as it does that. So it's telling me each individual box, is the box checked, is it not checked? And so this is one thing you'll notice as you do prompt engineering. In our previous prompts, we were kind of letting Claude decide how much it wanted to tell us about what it saw in the form. Here, because I've told it carefully examine each and every box, it's very carefully examining each and every box. And that might not be what we want in the end, so that's something we might change. But it's also going to give me these other things that I asked for in XML tags. So a nice analysis of the form, the accident summary so far. It's going to give me a sketch analysis, and it's going to continue to say that vehicle B appears to be clearly at fault. In this example, it's a pretty simple example. With more complicated drawings, less clarity in the forms, this kind of step-by-step thinking for Claude is really impactful in its ability to make a correct assessment here. So I think we'll go back to the slides, and Christian's going to talk about a last kind of piece that we might add to this to really make it useful for a real-world task.
Indeed, thank you so much. So as Hannah mentioned, we sort of set the stage in this prompt to make sure that Claude's really acting on our behalf in the right manner. And a key step that we also add towards the end of this prompt, that I'm going to show you in a second, is a simple sort of guidelines or reminder part as well. So just strengthening and reinforcing exactly what we want to get out of it. And one important piece is actually output formatting. You can imagine if you're a data engineer working on this LLM application, all this sort of fancy preamble is great, but at the end of the day, you want your piece of information to be stored in, let's say, your SQL database, wherever you want to store that data, and the rest of it that is necessary for Claude to sort of give its verdict isn't really that necessary for your application. You want the nitty-gritty information for your application. So if we transition back to the console, you'll see here that we just added a simple importance guidelines part. And again, this is just reinforcing the sort of mechanical behavior that we want out of Claude here. We want to make sure that the summary is clear, concise, and accurate. We want to make sure that nothing is sort of impeding in Claude's assessment, apart from the data it's analyzing. And then finally, when it comes to output formatting, in my case here, I'm just going to ask Claude to wrap its final verdict. All other stuff I'm actually going to ignore from my application and just look at what it's actually assessing. And that is, I can use this if I want to build some sort of analytics tool afterwards as well, or if I just want a clear-cut determination, this is a way I can do so. So if I just run this here, you'll see it's going through the same sort of process that we've seen before. In this case, it's much more succinct because we've asked it to summarize its findings in a much more straightforward manner. And then finally, towards the end, you'll see that it'll wrap my output in these final verdict XML tags. So you can see that during this demo, we've gone from a skiing accident to sort of unconfident, insecure outputs from perhaps a car accident in the second version to now a much more strictly formatted, confident output that we can actually build an LLM application around and actually help, a real-world car insurance company, for example. Finally, if we transition back to the slides, another key way of shaping Claude's output is actually putting words in Claude's mouth, or as we call it, pre-filled responses. You could imagine that parsing XML tags is nice and all, but maybe you want a structured JSON output to make sure that it's JSON serializable and you can use this in a subsequent call, for example. This is quite simple to do. You could just add that Claude needs to begin its output with a certain format. This could be, for example, a open squarely bracket, for example, or even in this case that we see in front of us, this would be an XML tag for itinerary. In our case, it could also be that final verdict XML tag. And this is just a great way of, again, shaping how Claude is supposed to respond without all the preamble if you don't want that, even though that is also key in shaping its output to make sure that Claude is reasoning through the steps that we wanted. So in our case here, we would just wrap it in the final verdict and then parse it afterwards. But you can use prefill as well. Now, finally, one step that I would like to highlight here as well is that both Claude 3.7 and especially Claude 4, of course, is a sort of hybrid reasoning model, meaning that there's extended thinking at your disposal. And this is something we want to highlight because you can use extended thinking as a crutch for your prompt engineering. basically you can enable this to make sure that Claude actually has time to think. It adds this thinking tags and the scratchpad. And the beauty of that is that you can actually analyze that transcript to understand how Claude is going about that data. So as we mentioned, we have these checkboxes where it goes through step by step of the scenario that transpired for the accident. And in many ways there, you can actually try to help Claude in building this into the system prompt itself. It's not only more token efficient, but it's a good way of understanding how these intelligent models that don't have our intuition actually go about the data that we provide them. And because of that, it's quite key in actually trying to break down how your system prompt can get a lot better. And with that said, I think I'd like to thank all of you for coming today. We'll be around as well, so if you have any questions on prompting, please go ahead. I know there's a prompting.
If you want to learn more about prompting, in an hour we have prompting for agents. And right now we have an amazing demo of Claude Plays Pokemon, so don't go anywhere for that. And as Christian said, we'll be around all day, so I know we didn't have time for Q&A in this session, but please come find us if you want to chat. And thank you guys for coming.
Thank you so much.
All right. Thank you everyone for joining us. So we're picking up with prompting for agents. Hopefully you were here for Prompting 101, or maybe you're just joining us. But I'll give a little intro. My name's Hannah. I'm part of the Applied AI team in Anthropic.
Hi, I'm Jeremy. I'm on our Applied AI team as well, and I'm a product engineer.
So we're going to talk about prompting for agents. So we're going to switch gears a little bit, move on from the basics of prompting, and talk about how we do this for agents, like playing Pokemon. So hopefully you were here for Prompting 101, or maybe you have some familiarity with basic prompting. So we're not going to go over the really kind of basic console prompting or interacting with Claude in the desktop today, but just a refresher, we think about prompt engineering as kind of programming in natural language. You're thinking about what your agent or your model is going to be doing, what kind of tasks it's accomplishing. You're trying to clearly communicate to the agent, give examples where necessary, and give guidelines. We do follow kind of a very specific structure for console prompting. I want you to remove this from your minds because it could look very different for an agent. So for an agent, you may not be laying out this type of very structured prompt. It's actually going to look a lot different. We're going to allow a lot of different things to come in. So I'm going to turn it over, or I'm going to talk about what agents are, and then I'll turn it over to Jeremy to talk about how we do this for agents. So hopefully you have a sense in your mind of what an agent is. At Anthropic, we like to say that agents are models using tools in a loop. So we give the agent a task, and we allow it to work continuously and use tools as it thinks fit, update its decisions based on the information that it's getting back from its tool calls, and continue working independently until it completes the task. So we kind of keep it as simple as that. The environment, which is where the agent is working, the tools that the agent has, and the system prompt is just where we tell the agent what it should be doing or what it should be accomplishing. And we typically find the simpler you can keep this, the better. Allow the agent to do its work, allow the model to be the model, and kind of work through this task. So when do you use agents? You do not always need to use an agent. In fact, there's many scenarios in which you won't actually want to use an agent. There are other approaches that would be more appropriate. Agents are really best for complex and valuable tasks. It's not something you should deploy in every possible scenario. You will not get the results that you want, and you'll spend a lot more resources than you maybe need to. So we'll talk a little bit about checklist or kind of ways of thinking about when you should be using an agent and when maybe you don't want to be using an agent. So is the task complex? Is this a task that you, a human, can think through a step-by-step process to complete? If so, you probably don't need an agent. You want to use an agent where it's not clear to you how you'll go about accomplishing the task. You might know where you want to go, but you don't know exactly how you're going to get there, and what tools and what information you might need to arrive at the end state. Is a task valuable? Are you going to get a lot of value out of the agent accomplishing this task? Or is this a kind of a low value task or workflow? In that case, a workflow might also be better. You don't really want to be using the resources of an agent unless this is something you get that's highly leveraged. It's maybe revenue generating, it's something that's really valuable to your user. Again, it's something that's complex. The next piece is, are the parts of the task doable? So when you think about the task that has to occur, would you be able to give the agents the tools that it needs in order to accomplish this task? If you can't define the tools, or if you can't give the agent access to the information or the tool that it would need, you may want to scope the task down If you can define and give to the agent the tools that it would want, that's a better use case for an agent. The last thing you might want to think about is the cost of errors or how easy it is to discover errors. So if it's really difficult to correct an error or detect an error, that is maybe not a place where you want the agent to be working independently. You might want to have a human in the loop in that case. If the error is something that you can recover from, or if it's not too costly to have an error occurring, then you might continue to allow the agent to work independently. So to make this a little bit more real, we'll talk about a few examples. I'm not going to go through each single one of these, but let's pick out a few that will be pretty clear or intuitive for most of us. So coding, obviously. All of you are very familiar with using agents in coding. Coding is a great use case. We can think about something like a design document, and although you know where you want to get to, which is raising a PR, you don't know exactly how you're going to get there. It's not clear to you what you'll build first, how you'll iterate on that, what changes you might make along the way, depending on what you find. This is high value. You're all very skilled. If an agent, if an agent is able, this is like more like what the midway is like at night. I feel more at home now. Claude is great at coding, and this is a high value use case, right? If your agent is actually able to go from a design document to a PR, that's a lot of time that you, a highly skilled engineer, are saved, and you're able to then spend your time on something else that's higher leverage. So great use case for agents. A couple other examples I'll mention here. Maybe we'll talk about the cost of error. So search, if we make an error in the search, there's ways that we can correct that, right? So we can use citations, we can use other methods of double checking the results. So if the agent makes a mistake in the search process, this is something we can recover from, and it's probably not too costly. Computer use, this is also a place where we can recover from errors. We might just go back, we might try clicking again. It's not too difficult to allow Claude just to click a few times until it's able to use the tool properly. Data analysis, I think, is another interesting example, kind of analogous to coding. We might know the end result that we want to get to. We know a set of insights that we want to gather out of data, or a visualization that we want to produce from data. We don't know exactly what the data might look like. So the data could have different formats. It could have errors in it. It could have it could have granularity issues that we're not sure how to disaggregate. We don't know the exact process that we're going to take in analyzing that data, but we know where we want to get in the end. So this is another example of a great use case for agents. So hopefully these make sense to you, and I'm going to turn it over to Jeremy now. He has some really rich experience building agents at Anthropic, and he's going to share some best practices for actually prompting them well and how to structure a great prompt for an agent.
Thanks, Hannah. Hi, all. Yeah, so prompting for agents. I think some things that we think about here, I'll go over a few of them. We've learned these experiences mostly from building agents ourselves. So some agents that you can try from Anthropic are Claude Code, which works in your terminal and sort of agentically browses your files and uses the bash tool to really accomplish tasks in coding. Similarly, we have our new advanced research feature in Claude.ai. And this allows you to do hours of research. For example, you can find hundreds of startups building agents, or you can find hundreds of potential prospects for your company. And this allows the model to do research across your tools, your Google Drive, web search, and stuff like that. And so in the process of building these products, one thing that we learned is that you need to think like your agents. This is maybe the most important principle. The idea is that essentially you need to understand and develop a mental model of what your agent is doing and what it's like to be in that environment. So the environment for the agent is a set of tools and the responses it gets back from those tools. In the context of Claude Code, the way you might do this is by actually simulating the process and just imagining if you were in Claude Code's shoes, given the exact tool descriptions it has and the tool schemas it has, would you be confused, or would you be able to do the task that it's doing? If a human can't understand what your agent should be doing, then an AI will not be able to either. And so this is really important for thinking about tool design, thinking about prompting, is to simulate and go through their environment. Another is that you need to give your agents reasonable heuristics. And so, Hannah mentioned that prompt engineering is conceptual engineering. What does that really mean? It's one of the reasons why prompt engineering is not going away, and why I personally expect prompting to get more important, not less important, as models get smarter. This is because prompting is not just about text. It's not just about the words that you give the model. It's about deciding what concepts the model should have and what behaviors it should follow to perform well in a specific environment. So for example, Claude Code has the concept of irreversibility. It should not take irreversible actions that might harm the user or harm their environment. So it will avoid these kinds of harmful actions or anything that might cause irreversible damage to your environment or to your code or anything like that. So that concept of irreversibility is something that you need to instill in the model and be very clear about. And think about the edge cases. How might the model misinterpret this concept? How might it not know what it means? For example, if you want the model to be very eager and you want it to be very agentic, well, it might go over the top a little bit. It might misinterpret what you're saying and do more than what you expect. And so you have to be very crisp and clear about the concepts you're giving the models. Some examples of these reasonable heuristics that we've learned. One is that while we were building research, we noticed that the model would often do a ton of web searches when it was unnecessary. For example, it would find the actual answer it needed, like maybe it would find a list of scale-ups in the United States, and then it would keep going, even though it already had the answer. And that's because we hadn't told the model explicitly, when you find the answer, you can stop. You no longer need to keep searching. Similarly, we had to give the model sort of budgets to think about. For example, we told it that for simple queries, it should use under 5 tool calls, but for more complex queries, it might use up to 10 or 15. So these kinds of heuristics that you might assume the model already understands, you really have to articulate clearly. A good way to think about this is that if you're managing maybe a new intern who's fresh out of college and has not had a job before, how would you articulate to them how to get around all the problems they might run into in their first job? And how would you be very crisp and clear with them about how to accomplish that? That's often how you should think about giving heuristics to your agents, which are just general principles that it should follow. They may not be strict rules, but they're sort of practices. Another point is that tool selection is key. So as models get more powerful, they're able to handle more and more tools. Sonnet 4 and Opus 4 can handle up to 100 tools, even more than that if you have great prompting. But in order to use these tools, you have to be clear about which tools it should use for different tasks. So for example, for research, we can give the model access to Google Drive. We can give it access to MCP tools like Sentry or Datadog or GitHub. It can search across all these tools. But the model doesn't know already which tools are important for which tasks, especially in your specific company context. For example, if your company uses Slack a lot, maybe it should default to searching Slack for company-related information. All of these questions about how the model should use tools, you have to give it explicit principles about when to use which tools and in which contexts. And this is really important, and it's often something I see where people don't prompt the agent at all about which tool to use, and they just give the model some tools with some very short descriptions. And then they wonder, like, why isn't the model using the right tool? Well, it's likely because the model doesn't know what it should be doing in that context. Another point here is that you can guide the thinking process. So people often sort of turn extended thinking on and then let their agents run and assume it will get out of the box better performance. Actually, that assumption is true. Most of the time, you will get out of the box better performance, but you can squeeze even more performance out of it if you just prompt the agent to use its thinking well. So for example, for search, what we do is tell the model to plan out its search process. So in advance, it should decide how complicated is this query, how many tool calls should I use here, what sources should I look for, how will I know when I'm successful. We tell it to plan out all these exact things in its first thinking block. And then a new capability that the Claude 4 models have is the ability to use interleaved thinking between tool calls. So after getting results from the web, we often find that models assume that all web search results are true, right? They don't have any, we haven't told them explicitly that this isn't the case. And so they might take these web results and run with them immediately. So one thing we prompted our models to do is to use this interleaved thinking to really reflect on the quality of the search results and decide if they need to verify them, if they need to get more information, or if they should add a disclaimer about how the results might not be accurate. Another point when prompting agents is that agents are more unpredictable than workflows or just classification type prompts. Most changes will have unintended side effects. This is because agents will operate in a loop autonomously. And so for example, if you tell the agent, keep searching until you find the correct answer, find the highest quality possible source and always keep searching until you find that source. What you might run into is the unintended side effect of the agent just not finding any sources. Maybe this perfect source doesn't exist for the query, and so it will just keep searching until it hits its context window. And that's actually what we ran into as well. And so you have to tell the agent, if you don't find the perfect source, that's OK. You can stop after a few tool calls. So just be aware that your prompts may have unintended side effects, and you may have to roll those back. Another point is to help the agent manage its context window. The Claude 4 models have a 200K token context window. This is long enough for a lot of long-running tasks, but when you're using an agent to do work autonomously, you may hit this context window. And there are several strategies you can use to sort of extend the effective context window. One of them that we use for Claude Code is called compaction. And this is just a tool that the model has that will automatically be called once it hits around 190,000 tokens, so near the context window. And this will summarize or compress everything in the context window to a really dense but accurate summary that is then passed to a new instance of Claude with this summary, and it continues the process. And we find that this essentially allows you to run infinitely with Claude Code. You almost never run out of context. Occasionally, it will miss details from the previous session, but the vast majority of the time, this will keep all the important details, and the model will sort of remember what happened in the last session. Similarly, you can sort of write to an external file. So the model can have access to an extra file, and these Claude 4 models are especially good at writing memory to a file. And they can use this file to essentially extend their context window. Another point is that you can use sub-agents. We won't talk about this a lot here, but essentially, if you have agents that are always hitting their context windows, you may delegate some of what the agent is doing to another agent, which can sort of, for example, you can have one agent be the lead agent, and then sub-agents do the actual searching process. Then the sub-agents can compress the results to the lead agent in a really dense form that doesn't use as many tokens. And then the lead agent can give the final report to the user. So we actually use this process in our research system. And this allows you to sort of compress what's going on in the search and then only use the context window for the lead agent for actually writing the report. So this kind of multi-agent system can be effective for limiting the context window. Finally, you can let Claude be Claude. And essentially what this means is that Claude is great at being an agent already. You don't have to do a ton of work at the very beginning. So I would recommend just trying out your system with sort of a bare bones prompt and bare bones tools and seeing where it goes wrong and then working from there. Don't sort of assume that Claude can't do it ahead of time, because Claude often will surprise you with how good it is. I talked already about tool design, but essentially the key point here is you want to make sure that your tools are good. What is a good tool? It will have a simple, accurate tool name that reflects what it does. You'll have tested it and make sure that it works well. It'll have a well-formed description so that a human reading this tool, like imagine you give a function to another engineer on your team. Would they understand this function and be able to use it? You should ask the same question about the agent computer interfaces or the tools that you are giving your agent. Make sure that they're usable and clear. We also often find that people will give an agent a bunch of tools that have very similar names or descriptions. So for example, you give it 6 search tools, and each of the search tools searches a slightly different database. This will confuse the model. So try to keep your tools fairly distinct and combine similar tools into just one. So one quick example here is just that you can have an agent, for example, use these different tools to first search the inventory in a database, run a query. Based on the information it finds, it can reflect on the inventory, think about it for a little bit, then decide to generate an invoice, generate this invoice, think about what it should do next, and then decide to send an email. And so this loop involves the agent getting information from the database, which is its external environment, using its tools, and then updating based on that information until it accomplishes the task. And that's sort of how agents work in general. So let's walk through a demo real quick. I'll switch to my computer. So you can see here that this is our console. The console is a great tool for sort of simulating your prompts and seeing what they would look like in a UI. And I used this while we were iterating on research to sort of understand what's really going on and what the agent's doing. This is a great way to think like your agents and sort of put yourself in their shoes. So you can see we have a big prompt here. It's not sort of super long. It's around 1,000 tokens. It involves the researcher going through a research process. We tell it exactly what it should plan ahead of time. We tell it how many tool calls it should typically use. We give it some guidelines about what facts it should think about, what makes a high-quality source, stuff like that. And then we tell it to use parallel tool calls. So run multiple web searches in parallel at the same time, rather than running them all sequentially. And then we give it this question. How many bananas can fit in a Rivian R1S? This is not a question that the model will be able to answer because the Rivian R1S came out very recently. It's a car. It doesn't know in advance all the specifications and everything, so it'll have to search the web. Let's run it and see what happens. You'll see that at the very beginning, it will think and break down this request. And so it realizes, OK, web search is going to be helpful here. I should get cargo capacity. I should search Woo! And you see here, it ran 2 web searches in parallel at the same time. That allowed it to get these results back very quickly. And then it's reflecting on the results. So it's realizing, OK, I found the banana dimensions. I know that the USDA identifies bananas as 7 to 8 inches long. I need to run another web search. Let me convert these to more standard measurements. You can see it's using tool calls interleaved with thinking, which is something new that the Claude 4 models can do. Finally, it's running some calculations. It's thinking about how many bananas could be packed into the cargo space of the truck. And it's running a few more web searches. You can see here that this is a fairly complex task, but it can now provide an answer. It's done a bunch of web searches, and it will tell you how many bananas can it fit. Pending. Approximately 48,000 bananas. I've seen the model estimate anything between 30,000, 50,000. I think the right answer is around 30,000, so this is roughly correct. Going back to the slides, I think that this sort of approach of testing out your prompt, seeing what tools the model calls, reading its thinking blocks, and actually seeing how the model's thinking will often make it really obvious what the issues are and what's going wrong. So you'll test it out, and you'll just see, like, OK, maybe the model's using too many tools here. Maybe it's using the wrong sources, or maybe it's just following the wrong guidelines. So this is a really helpful way to sort of think like your agents and make them more concrete. Switching back to the slides. OK, so evals. Evaluations are really important for any system. They're really important for systematically measuring whether you're making progress in your prompt. Very quickly, you'll notice that it's difficult to really make progress on a prompt if you don't have an eval that tells you meaningfully whether your prompt is getting better and whether your system is getting better. But evals are much more difficult for agents. Agents are long running. They do a bunch of things. They may not always have a predictable process. Classification is easier to eval because you can just check, did it classify this output correctly? But agents are harder. So a few tips to make this a bit easier. One is that the larger the effect size, the smaller the sample size you need. And so this is sort of just a principle from science in general, where if an effect size is very large, for example, if a medication will cure people immediately, you don't really need a large sample size of a ton of people to know that the model is that this treatment is having an effect. Similarly, when you change a prompt, if it's really obvious that the system is getting better, you don't need a large eval. I often see teams think that they need to set up a huge eval of like hundreds of test cases and make it completely automated when they're just starting out building an agent. This is a failure mode, and it's an anti-pattern. You should start out with a very small eval and just run it and see what happens. You can even start out manually. But the important thing is to just get started. I often see teams delaying evals because they think that they're so intimidating or that they need such a sort of intense eval to really get some signal. But you can get great signal from a small number of test cases. You just want to keep those test cases consistent and then keep testing them so you know whether the model and the prompt is getting better. You also want to use realistic tasks. So don't just sort of come up with arbitrary prompts or descriptions or tasks that don't really have any real correlation to what your system will be doing. For example, if you're working on coding tasks, you won't want to give the model just competitive programming problems, because this is not what real-world coding is like. You'll want to give it realistic tasks that really reflect what your agent will be doing. Similarly, in finance, you'll want to sort of take tasks that real people are trying to solve and just use them to evaluate whether the model can do those. This allows you to really measure whether the model is getting better at the tasks that you care about. Another point is that LLM as judge is really powerful, especially when you give it a rubric. So agents will have lots of different kinds of outputs. For example, if you're using them for search, they might have tons of different kinds of search reports with different kinds of structure. But LLMs are great at handling lots of different kinds of structure and text with different characteristics. And so one thing that we've done, for example, is given the model just a clear rubric and then ask it to evaluate the output of the agent. For example, for search tasks, we might give it a rubric that says, check that the model looked at the right sources, check that it got the correct answer. In this case, we might say, check that the model guessed that the amount of bananas that can fit in a Rivian R1S is between like 10,000 and 50,000. Anything outside that range is not realistic. So you can use things like that to sort of benchmark whether the model is getting the right answers, whether it's following the right process. At the end of the day, though, nothing is a perfect replacement for human evals. You need to test the system manually. You need to see what it's doing. You need to sort of look at the transcripts, look at what the model is doing, and sort of understand your system if you want to make progress on it. Here are some examples of evals for agents. So one example that I sort of talked about is answer accuracy. And this is where you just use an LLM as judge to judge whether the answer is accurate. So for example, in this case, you might say the agent needs to use a tool to query the number of employees and then report the answer. And then you know the number of employees at your company, so you can just check that with an LLM as judge. The reason you use an LLM as judge here is because it's more robust to variations. For example, if you're just checking for the integer 47 in this case in the output, that is not very robust. And if the model says 47 as text, you'll grade it incorrectly. So you want to use an LLM as judge there to be robust to those minor variations. Another way you can eval agents is tool use accuracy. Agents involve using tools in a loop. And so if you know in advance what tools the model should use or how it should use them, you can just evaluate if it used the correct tools in the process. For example, in this case, I might evaluate the agent should use web search at least 5 times to answer this question. And so I could just check in the transcript programmatically, did the tool call for web search appear 5 times or not? Similarly, you might check in this case, in response to the question, book a flight, the agent should use the search flights tool. And you can just check that programmatically. And this allows you to make sure that the right tools are being used at the right times. Finally, a really good eval for agents is TauBench. You can sort of look this up. TauBench is a sort of open source benchmark that shows that you can evaluate whether agents reach the correct final state. So a lot of agents are sort of modifying a database or interacting with a user in a way where you can say the model should always get to this state at the end of the process. For example, if your agent is a customer service agent for airlines and the user asks to change their flight, at the end of the agentic process in response to that prompt, it should have changed the flight in the database. And so you can just check at the end of the agentic process, was the flight changed? Was this row in the database changed to a different date? And that can verify that the agent is working correctly. This is really robust, and you can use it a lot in a lot of different use cases. For example, you can check that your database was updated correctly. You can check that certain files were modified, things like that, as a way to evaluate the final state that the agent reaches. And that's it from us. We're happy to take your questions.
Actually, I think we have to go.
Can you talk about building prompts for agents? Are you giving it kind of longer prompts first and then iterating, or are you starting kind of chunk by chunk? What's that look like? And can you show sort of a little bit more on that thought process?
That's a great question. Could I switch back to my screen, actually? I just want to sort of show the demo. Thank you. Yeah, so you can see this is sort of a final prompt that we've arrived at, but this is not where we started. I think the answer to your question is that you start with a short, simple prompt. So in this case, I might start with something very short. I'll just delete this for now, and I'll say, like, search the web to answer the question. And I might just say search the web agentically. I'll change this to a different question. How good are the Claude 4 models? And then we'll just run that. And so you'll want to start with something very simple and just see how it works. You'll often find that Claude can do the task well out of the box. But if you have more needs and you need it to operate really consistently in production, you'll notice edge cases or small flaws as you test with more use cases. And so you'll sort of add those into the prompt. So I would say building an agent prompt, what it looks like concretely is start simple, test it out, see what happens, iterate from there, start collecting test cases where the model fails or succeeds, and then over time try to increase the number of test cases that pass. And the way to do this is by sort of adding instructions, adding examples to the prompt. But you really only do that when you find out what the edge cases are. And you can see that it thinks that the models are indeed good. So that's great.
When I do like normal prompting and it's not agentic, I'll often give like a few shot example of like, hey, here's like input, here's output. This works really well for like classification tasks, stuff like that, right? Is there a parallel here in this like agentic world? Totally. Are you finding that that's ever helpful, or should I not think about it that way?
That is a great question. Yeah, so should you include few shot examples in your prompt, and sort of traditional prompting techniques involve like saying the model should use a chain of thought and then giving it few shot examples, like a bunch of examples to imitate. We find that these techniques are not as effective for state-of-the-art frontier models and for agents. The main reason for this is that if you give the model a bunch of examples of exactly what process it should follow, that just limits the model too much. These models are smarter than you can predict, and so you don't want to tell them exactly what they need to do. Similarly, chain of thought has just been trained into the models at this point. The models know to think in advance. They don't need to be told, like, use chain of thought. But what we can do here is, one, you can tell the model how to use its thinking. So I talked about earlier, rather than telling the model, you need to use a chain of thought, it already knows that. You can just say, use your thinking process to plan out your search, or to plan out what you're going to do in terms of coding. Or you can tell it to remember specific things in its thinking process. And that sort of helps the agent stay on track. As far as examples go, you'll want to give the model examples, but not too prescriptive. I think we are out of time, but you can come up to me personally, and I'll talk to y'all after.
Thanks.
Thank you.
Thanks for coming.